It's recording, it's live. Thank you.
Yeah, so but don't go too far away from the
From the
camera,
computer,
so,
okay.
because the microphone is here.
Yeah, I stay here.
And I can distribute stuff if needed. So just a very brief introduction. Patricio is a photographer. He's based in Barcelona, and he's been working on many different projects, like a photographer, a reporter, and artistic projects, sports, and so on. And he recently got interested in astrophotography and as how we can capture in one single snapshot a very long series of observations. So what you're about to see, it's basically this done at the local level. And so, Patricio, the floor is yours. And
Thank you.
when you have.
Thank you, 3 minutes. Thank you, Nicolas. Thank you for the IPAG. Actually, yes, I did this project with Nico, and with the IPA we have this beautiful rooftop. And the idea is to show you how I create the project, and maybe you can create your own project with maybe with your kids or at school or in your institute. So in 15 or 20 minutes, I want to show you what we did.
Working?
No, it's not working.
Oh, it is.
So basically, the idea is to take picture of the sun with a simple coffee can. So I have a lot of coffee can of Illy's. There are cans like 250 grams that you can, if you can pass through the public, will be great. So that's a simple can that I make a pinhole of 1 millimeter, and then I put some photographic paper inside, and we prepare 75 solar cans in total. So this is the basic. Is very simple and very cheap to make yourself with the paper, photographic paper that you develop pictures. So. What happens when you take one picture, so simply one picture in 1/1000 of a second, you have the sun in the middle of the picture. What happens if you take 13 pictures of 1/1000 of a second in the same frame? You have 13 sun. And then what happens if you take infinite? So it's a continuous path of the sun. You have this is the path of the sun in one afternoon, let's say. So the idea with Solargraphy is to make this picture, but in 3 or 6 months period. So that's the main idea. So here we are in Grenoble. This is the latitude and the longitude, and this is the path of the sun between the 21 of June until the 21 of December. So thank you. So there is a super funny website. You can play with the path of the sun here. So I put the latitude. Here we are in Grenoble at 45 north, more or less, and longitude 5 east there. And if I take play, oops. So this is the path of the sun in one day. Yeah. So with the can, we are recording the path of the sun in the sky. That's the idea. So you see the sun goes up and then we're going down. So here you have the date and the time. Yeah, 21 October. The sun is going slightly down until 21 of December. So here, let's go back to, I think it's okay. Yeah, thank you, Nico. He's my assistant. So we did the installation of the rooftop of the IPA, just above this room. We prepared the cans, and then Antoine with the group of Nico make the development. So they pick up the cans and at 3 and 6 months, and we are going to discuss the image and conclusions. So this is the rooftop of the IPAG. Yeah. So we put the cans on the edge of the rooftop, looking west, looking south, looking east, and looking north. So we put many cans to have many how is it,
Presentations.
yes, many orientations and many samples. So you can see the cans from the street, put here, orient to the east, and you have to the west, and you have the dome there. Then Nico is there cleaning and putting the cans with some kind of silicone, and we place the can in many just ways, looking up, looking every direction. So we wait 3 months. So after 3 months, the team pick up some cans. So they open the cans and they dry the cans and then they scan the picture that they are inside. So I prepare the cans. The idea is if you can pass the cans on the public, there is one can there you can open. Maybe one is empty and the other has a picture inside. No, that
Years of work.
and there are two more cans. Okay, open the cans. There is one picture inside. Stick to the can that that one that can is from today. So we put that can on June 2024, and I pick up the can this morning. So 1 year of the picture. We're going to see that. So image, the results. Yeah, this is one image. I show you the image and then I discuss afterwards. Another one. This is the original image. Scan, but the original one. One image looking west. This is the same image looking west. This image is from one can. I don't know which one, but one can. You can see the hospital, the white building is the hospital of Grenoble. And then the 21st of June is here until 21st of December on the left. So approximately 180 days, it's 6 months, and it's 8 million of seconds. This is the dome oriented north, so there is no sun. This is one picture oriented thing west or east, and we can see a bright light there. The bright light is we place the cans on the June 13, so it's 1 week before the solstice, and the how do you say the sun goes up until 21st and then goes down. So it's two how do you say two pass. The sun pass twice over the same surface of the paper. More pictures. These 270 degrees, like a panoramic with a cupola, and there are the cans there. Photography with another can. So it's like a zoom. This one is the same picture with the colorized with AI. So I think Pedro or Mario, I don't know, colorized, yeah, with the AI. And I want to show just this is important. I think we can see every path of the sun, and if there is some kind of cloudy sky, if it's rain, if it's sun. And the deformation also of the path is interesting because it's the can is like a fisheye. It's an if you know about photography, it's like an 8 millimeters or 6 or 8 millimeters. So it's very wide open. So conclusions. I prepare 50 cans more or less. We put 50 and we pick up 25, so more or less 50%. And in 25 cans, I scan 22 images, like 90%. The other was because bad weather if you move the can, the picture it's completely blur, or maybe one or two disappear, but we pick up more or less 50%. So in this picture, that's for me the most interesting. So we can see the weather of the period between June 13 and September 9 that we pick up the can. So the project begins on June 13, 1 week before um, summer. And then uh, here, yeah. So we have 1 week until 21st, and then the sun starts going down. And when you see the bright trail is like a double exposure because there is sun, 1 day of sun, and then coming back another day of sun. And if there is the black trail, there is no sun. I don't know if it's cloudy, rainy, but there is no sun. So you have a black trail, a big black trail between July 6th and July 13. And then after July 14 to July 22nd, you have another black trail here. There. And there's 1 day, July 14, of sunlight. And then I start searching about the weather, and I see that on Sunday 14 there is plenty of sun. And then starting to have on 15, 16 until the 20, 21, 20, 22, it's like rainy or cloudy. There is no sun, and you can see that on the picture. Yeah, between the arrows. And another one. So this can was picked on. We're great with time. This can was picked on September 9. And 3 days before we pick up the can, we can see 3 trails in the dome. Here. 1, 2, and 3 trails, 3 days before. And that means that the dome did not come back to the same position. And we can see also with this kind of solargraphy, we can study motion of object. Maybe you can see the trees, they are blur because the trees, it's not like a building, so the tree moves with the wind or with the rain, so there are blur. Instead, this is more sharp. A Cartesian sun path. So you have the picture of collect with the can, and this is Cartesian path. Actually, the last day was September 9. Is the brown one. The brown one. The brown line is the last line, so the above line. So, and this is more or less like a conclusion that we have together with the team. So, what can we do with solargraphy? We can obviously see the movement of the sky. We can see we can study the weather, the chemistry of the salt of the paper, and then the magnetism of the can. We can see if the hole if magnetic, there is rust, an oxide stick on the hole. That will be just definition. It's not so good definition of the picture, stationary objects, and maybe I think that the best is doing workshops with primary or secondary students to show astronomy or photography, or we can make art and science together, and that's the main idea of solargraphy, and also having fun and teaching patience, because you have six is one picture is 6 months period, or three to 6 months period. So when you put the can, you need to wait, let's say 3 or 6 months to collect the data. So that's my small presentation. So if you have question and answers to me or maybe to Nico, we can solve that. That's good.
Before some quick questions, if there are any, we can
Yeah.
show one picture from today after 1 year exposure.
1 year exposure. I pick up the picture this morning and I scan the picture with my phone.
And actually, there are a couple of, it's a bit hard to see in the screen, but here you can guess that there is the spectrum of a can, because basically, do you know why? Do we see half? I mean, we can see through the can.
Because you removed it during the.
Of course.
Yeah.
This was one of the first we removed. So then at some point it was printed a bit on the paper, and then it was.
Yeah, it's like a phantom can. Instead of phantom workshop, phantom can. Yeah.
Are there any questions or advice, Rafael? And then Jeff?
Great talk, great talk about the photography. How do you know if they're not gonna get overexposed, or like how do you measure the?
No, I put the can and I put the paper, and the sun goes directly to the paper. It's not overexposed because the paper has a very low sensibility. So even with a 2 years period, it's not overexposed. Yeah.
So it's a special type of paper that we put in there.
It's not. Actually, if I take the picture of, let's say, 1 day, you won't see anything. It's completely dark. Yeah.
For workshops with kids and stuff, you need paper which reacts much faster, so you can take quick pictures and they can see. Jeff?
Yeah.
I had the exact same question.
Okay. Yes. So,
How do you make sure that the can don't move?
I stick with industrial tape, and I put silicone. So yeah, and pray. No, and actually it depends on where you put the can. If you put the can in the middle of the square of your town, it will completely, or stolen, or someone when maybe touch it, and the project of that can, the picture of the can is completely lost.
actually, one of the cans fell, and we had two pictures at the same time. It was
Yeah.
a bit weird, but you can have funny things. A bit hard to explore.
Yeah.
One picture on the sides.
One more question, perhaps. So again, it's super easy to implement. Daniel?
What about weather? Like, no problems with moisture or?
A lot of moisture. One of the can is completely oxide, rust. I don't know.
It's rust, and it was
No, it's
like,
completely rust.
like we lost the you can see through, and when we remove some of them,
Yeah.
they were half. Some of them had like this of water inside.
Yeah.
So the paper, that's why we have a 50% recovery rate. So ideally, one should put this below a small something which protects it from rain.
It's more than moisture.
And when we open those things, yes, it's a bit nasty inside. Very nice.
You have the picture inside. There's a picture. Yeah. I didn't pick up yet the picture. You can see. Yeah.
And again, there is I can share Patricio's contact in case your local university or project would like to do something similar. It's very cheap in a way, because just between 1,000 and 2,000 to pay trips, installation, the time of revelation. So it's not that much money, and it might be a nice way to feature your university. And Patricio got in contact with a few other teams, and he's planning to do.
Yeah, we are going to do the same in Valencia, in Spain.
This
So
morning we put some more new cans, so we plan to do a comparison between the first year and the second year to show that you can monitor weather
Yeah.
over different years. Yeah, that's. There any no more questions? Perhaps no. Yes.
Will you try for longer than a year? And will it be worth it?
no, it's not worth because in 6 months you have from winter to summer, and then over 6 months the sun is that's the same path. So you are losing information, and in 1 year or in let's say in 18 months you are losing every information because the sun can pass over again the same path. And if I do this in let's say in a 10-year period, maybe this the path would be white, all white.
It's the average of
Yes, the average of season, I think, yes. So I think it's 1 year is max. 6 months would be great. 1 year, it's okay. And then after that, they can also suffer a lot, and you have a probability that you lost the can or the moisture, or it's, yeah, after, yeah, 1 year, it's okay. Yeah, it's saturate. I don't know how to say it.
So before concluding, we have some pictures we took this morning in case you want to see what comes out of the can. So if you're interested, we're gonna be here on the side.
That's the original one
These are
that.
the original papers.
Yes.
That then you need to scan to then do this kind of
Yeah.
post-processing.
I
But,
scan in,
yeah.
but that's the original. There are 7x7 paper.
Okay, so thank you very much for this again.
Thank you.
Now.